All right, in this video, we are going to talk about a new set of identities, and those are the double angle identities. So we're going to talk about the double angle identities for sine 2x, cosine 2x, and tan 2x. You can see the reason why they are called the double angle identities is because of the fact that there's a 2x on the left side of each one of these identities. So basically, 2 times something is double that. Okay, so each of these identities, what they do is to show you how to take a trigonometric function of double the angle in terms of uh, just the angle itself. So you'll see here on the left hand side of this one for sine, I have 2x. If you'll notice inside the trig functions on the right hand side of all of these, you're just going to have a single x in there. Okay, now the expression is more complicated, but this will allow you to calculate some of these values going both ways. If you know the information about x, well, then you can get it about 2x and vice versa. All right, so starting off with sine 2x, there's only one, and that is this one here. Sine 2x equals 2 sine x cosine x. You'll notice with cosine 2x and tan 2x, there are actually 3 double angle identities for each of those. But just to save space, I kind of have written it all on one line. It's to save space on this slide here. So we have the cosine of 2x is equal to cosine squared minus sine squared. Or, right, cosine 2x is equal to 1 minus 2 sine squared x. We also have that cosine 2x is equal to 2 cosine squared x minus 1. Okay? So now you might say, well, how do I know when to use which one? You basically have your choice as to which one you can use, or which one you can use in a various situation, but sometimes we'll see that one choice will be easier for a given problem than another choice might be. Okay? Like for instance, if you only knew the cosine of x and didn't know sine x, you would obviously choose this identity over here, this one, if you were calculating cosine of 2x. All right, and for tangent of 2x, there are also 3 different ones. Again, just to save space, I have written them all in one line here. You can use any of these that you like. One is only involving tangents. One is only involving cotangents, and this one involves cotangent and tangent here. Okay, so those are the double angle identities, right? You're allowed to assume that these are verified and true, even though we're not going to do that in this video. We will use these when we are working through the problems. Okay, so that's it for this one. In the next video, I will start working some examples using the double angle identities.